The idea for this project comes from a combination of two things. First is a common expressive gesture that DJs often use when they perform to large crowds, raising their hands to emphasize the music they play and connect with the audience. The second is the use of noise and sweeps in dance music production. Noise is often used in a number of ways, examples being to build up to the drop in a track or layer white noise over a snare. This project links these two ideas so that the common expressive gesture of raising your hand controls a filter applied to white noise and the pitch and speed of a synth affected by an LFO. The project is designed to accompany the equipment that is already used by DJs. Seeing as DJs are already performing, the design should be subtle enough to complement the set rather than becoming the main focus. For this reason, the hand gesture controls most of the sound by using an accelerometer. The parameters of the sound is then set by potentiometers. The movement of these components control a patch made in Max MSP. I'm using the Arduino object to read the sensors that are connected to the analog ports on the Arduino. The first sensor is an accelerometer that reads the arm movement. This controls a number of parameters. We then have a potentiometer to control filter resonance, and a potentiometer for both synth and noise gains. The values for these two parameters are toggled by switches connected to the digital inputs. When they are set to off, it sends a 0 to the number box, which effectively turns off the sound. There is a preset box triggered by a load bang, so the values for the scale objects are set when the patch is opened. The accelerometer values are scaled to range from 200 to 800 Hz. This value sets the frequency for 8 oscillators. Each oscillator frequency is an integer multiple of the original frequency. This is to generate harmonic timbres to give the sound character. The synth signal is then sent to a bandpass filter. The filter cutoff is also controlled by the accelerometer. The values are scaled to range from 600 to 2000 Hz. A cycle object is added to the frequency cutoff value to create an LFO effect that speeds up as the arm is raised. The sound is then sent to a cone filter with a 255 millisecond delay. This is to make the sound more interesting. For the noise sweep, a noise generator is fed to a bandpass filter. Once again, the filter cutoff is set by the accelerometer. This is scaled to range from 20 to 10,000 Hz. The output of the noise is then added to the synth and fed to the DAC. The accelerometer is soldered to a piece of variboard and housed in a small plastic box. The 3 wires connected to the accelerometer are covered and protected by red tubing. This connects to the main unit. The main unit consists of a basic mixer that turns the synth and noise on or off and allows the user to mix between the two. The larger knob controls the resonance of all the filters in the max patch. The components are connected through a small breadboard to the Arduino. Both the breadboard and the Arduino unit are properly secured. This makes the unit robust. The USB port is located at the front of the device.